Okay, hi and welcome to our video notes on complex numbers. What is a complex number? That's new to you. You should have never seen this before. Complex, does that mean that it's a lot of work? No, actually it's not. It's something that's fairly easy for us to take care of. So, let's talk about something that we are familiar with first so that we can figure out what these imaginary ones are. We're really just going to look at what they do, and we'll explore a little later in the class what they look like and kind of how they relate to a graph. But today we're just going to understand how we get them, or what we do with them. All right, so let's go ahead and take a look at this table here. And then this table, what we're going to do is kind of look at solving. And in solving and doing operations, we're going to get different sets of numbers. So you can kind of see the complexity as it works upwards into this imaginary set of numbers. So when we started, we did a bunch of linear problems. When we solved linears, most of them were whole numbers, which were negative whole numbers, which we call integers. That's kind of where we began with our solving process. We did work up into some more complex linear functions where if we solve this out, again, remember when we're solving, putting a 0 in for y, right, is how we indicate that we're solving. If we finish solving this, we notice that x is going to be equal to negative 4/3. That's a division, right? And that's a rational. So we've worked into that. Recently, we started doing square roots. And when we worked into square roots, we know that the get rid of a square is the inverse is a square root. So we would square root both sides and we'd end up with some square root of a number. And that is an irrational number, which we knew from before. Now let's talk about in this square root section a value under the radical, being that of a -1, that we said we couldn't deal with. But now we're going to give it a little bit of a definition so that we can work with it. And if you'll notice this one here, this quadratic, x squared plus 1 is equal to 0, if we went to solve it, we would square root and we'd end up with a square root of a -1. Well, what we're going to do is we're going to give it a special name, that negative, and we're going to move it out and give it a special, I don't want to call it a variable, we're going to give it a symbol. An I is what we're going to call it here. And we're going to leave it for now, right? And that's all we're going to do with it. So all we're going to need to know is what to do with a negative under the square root. That's really what this note section is about. So let's define an imaginary number then. An imaginary number then is quite literally, by definition, the square root of -1. Not any number, square root of -1. So let's talk about that. If I have -6, right, what is that really? It's -1, oops, there should be a times there, times 6. And if I had the square root of -6, we'd have the square root of -1 times the square root of 6. So we can separate them using our operations that we're familiar with. I don't know what happened there, but that got jumbled a bit. But the square root of a -1, then what we're going to do is anytime we find it, we're going to, let me clean that up so it looks better. Square root of -6 equals the square root of -1 times square root of 6. We're going to call it I. That's what we're going to do with it. That's our job. That's all you have to know about it right at this moment is that anytime that you have a -1, you're going to call it I. So I square root of 6, of course, we'd simplify that a little bit farther, but in this case, we'll get to the example. And if we do come up with one of these square roots of a negative value, so square root of -a here, we're going to pull the I out, and there's possible that the root stays there. That's perfectly fine. But we always want to place, and that's the important part about this, is it needs to go in front of the radical. Okay, or the square root. So let's do a couple examples then. So we're going to jump right into it. We're not going to mess around with any other square roots. Here's the square root of a -2. How do we deal with this negative underneath it? Before we said we couldn't do anything with it. It didn't have any solution. It does have solutions, but we have to address it properly. So our first job to do here is to go ahead and separate this into -1 times 2. Now we can go ahead and split that up then, the square root of -1 times the square root of 2 using our multiplication of radical property. And then in doing that, we're going to change this piece here. Let's even change colors. We're going to change that into I. And again, the operation that's between all of these always is an unsaid multiplication. Sometimes we don't write that, so we'd write I square root of 2 and we say, hey, that's what that would look like. What does it mean? Don't worry about that right now, but that's how you deal with a negative or what we call an imaginary number. All right, so let's do the square root of -12. Again, same process. We're going to take that and break it up into its parts. Remember, we also have to simplify in here, so 12 seems to have a perfect square factor in there, which is 3 times 4. All right, that makes 12. So let's start to break this up a little bit more. So we're going to say times 3 times 2 squared. Why do we want 2 squared? because this is why we're going to break this up into 3 radicals now. Square root of -1 times the square root of 3 times the square root of 2 squared. Why did we separate it? So we can do that and clearly see that the 2 now is not going to be inside of the radical. And this is going to transform itself into our new understanding of it, which is I. So before we completely clean this up, that would be the carry down, and that would be where we're at. But we like to have our numbers for imaginary, our constants or coefficients, and I out in front of the radical. So we're actually going to write it 2I square roots of 3. It does need to be in this form. You want your coefficient first, then you want your I, then a radical. Okay? Put it in that fashion at all times. All right, so I'm going to pause here. Oh, one other quick thing. If you don't have a radical, I will sit behind the coefficient by itself. You can kind of treat it a little bit like a variable, even though it's not. It doesn't change. It represents the square root of -1. All right, so I'm going to flip the page, and I'll meet you on the other side. Okay, here we are on the back side of the notes, and I'm going to introduce yet another set of numbers that you're not familiar with. We're going to call these complex numbers. Complex numbers are a mix of those imaginary numbers that we just talked about and real numbers that we're already familiar with. So we're going to mix them up, usually through addition and or subtraction there. But that's what a complex number is, a mix of them. A pure imaginary number is some form of a term that has an I, where a complex has an addition of a real number or a subtraction of a real number with it. Do you need to know any more than that? Not really. Not right now, that's all you need to know. So let's take a look at these. We do have a form that we need to write them in. This would be, I guess, standard form for complex numbers. You want to put your real number in front, your coefficient of I, and then any radicals after that. Okay, so make sure that you keep it in this form here. It does need to be written that way to be proper. All right, so let's get into some examples of this. And right now, all we're going to do is write these into complex form, okay, a plus bi. And they're not going to be in that form, obviously. But when we do that, we need to also keep in mind that we have to simplify our radicals as we go. So looking at this one, I've got the square root of -9 plus 6. Well, I don't want to start moving its position. The first thing I really want to do is simplify this radical of square root of -9. So I'm going to break it apart into two pieces, -1 times 3 squared. Right? Now we can forego writing them as separate. We can say that this radical and that square are going to reduce themselves out, and that this square root of -1 is going to turn into I. You can break it up and write it out, but for time's sake, let's just go ahead and write I times 3 plus 6. Now I like to leave it like that, and then I'll rearrange it once I've got it here. This is going to become 3i, and this 6 has to go out in front because it's the real number. So I'm going to put 6 first. Now I'm going to put 3 times I. That one's done. It's just that simple to write it into complex form. All right, let's go down and see if we can work with some operations of these though. Notice when we have these here, we've got a complex number plus a complex number, right? There's your real number plus your imaginary number, and the same thing over here. When there's a plus in between, there's no multiplication indicated, right? So we can really just drop the parentheses. And then we can start adding like terms. What are we adding like terms? Well, real numbers are going to add with real numbers, and imaginary numbers are going to add with imaginary numbers. They do act like a variable in that sense, meaning that the coefficients add, right, add and subtract, and the I stays the same. We've seen that pattern a lot. So you can see here that 5 and 3 are going to be combined to make 8, and then the 3i and the 8i are going to turn into 11i. Well, let's jump over here and do B, but notice B has a negative. Anytime we have a negative, if we're subtracting two different sets of terms or sums, in this case, we're subtracting a complex number from another complex number, we need to distribute first, that negative. Make sure that it's addressed to both terms inside that parentheses. So that's what I've done. I've changed both their signs. Now I'm going to put the i's together, and I'm going to put the real numbers together. So I've got a 7 and a -2, which is going to give me 5. And I'm going to check my i's here. I've got I, or -1i, and -4i, which is going to make -5i. Again, just that simple. Stuff that you're already familiar with, we're just adding it to a thing that you're not that familiar with. So that should be good, though, because you should be used to it now. All right, let's talk about the reduction of I. We're not going to get into it fully. We're really just going to deal with the reduction of I as a square. So what does I squared mean? Well, if I means the square root of -1, this means that I've got two of them, or the square root of -1 times square root of -1. Follow me so far? Well, if I put those under the same radical, doesn't that mean the square root of -1 squared? Why, sure it does. And then doesn't a square root and a square reduce because they're inverses, leaving you with just a -1? Remember that. We're going to need that in the next set. All right, so now that we know that, let's look at complex numbers and multiplication. Okay, so we just did addition and subtraction. Now we're going to do multiplication. So our rules apply. I don't like to use the term FOIL. Maybe you want to use a box, but I like to use I like to say the distributive property. So I'm going to take 7. I'm going to multiply it to both of these terms. So 7 times 2 is 14, and 7 plus or times 4i is plus 28i. And now I'm going to take this negative I and multiply it to that 2, or negative 2i. And I'm going to take that negative I and multiply it to that 4i, or negative 4i squared, because we multiplied two i's together. So they do operate just like variables in that sense. Well, now that we've got that, let's take a look at what we've got here. We've got some like terms. We've got some imaginary numbers there. We've got a real number here, but what do we do with this negative 4i squared? Well, let's address that first. So negative 4, nothing's going to happen to it. But I squared, we just saw, becomes -1. So let's change its form into -1. That's not so bad. Let's do one more step with that. -4 times -1 makes +4. So that's what this piece here reduces to. Let's finish up the rest of the problem then and see what we've got. 28i minus 2i is going to give me 26i, right? And there's that subtraction sign between it. And 14 is kind of hanging out right now. It's not doing anything at all. But you'll notice, let me just write these down one more level, get them on the same level as my 4 there. So that's what we've got. Now, what we have is another real number with another real number. The imaginary numbers, when they multiplied and became squared, kind of work themselves out because it's a square root of a -1 twice, and two negatives become a positive if you want to think of it that way. But now we've got to combine these two terms. So let's combine those. 14 and 4 make 18 plus 26i. So really, this is a key piece to this section of the notes under multiplication, and that only occurs under multiplication, right? If we're distributing, that's the only place you'll get to this I squared. So make sure you look at this example. Let's summarize everything that we've done. Under multiplication, we may have an I squared. I squared will change into -1, and then you should be able to write it as a complex number again. Okay, we also talked about complex numbers, putting them in the correct form, right? The complex number form, a plus bi. And we also talked about how they add together, or like terms of complex numbers, if you will, real numbers with real numbers and imaginary numbers with imaginary numbers. On the front page, let's just review. We talked about our number sets and how we got there, and exactly what an imaginary number is, which is the square root of -1, and we call it I. All right, so now you've seen all that. I will talk to you and see you in class. Have a good day.